Topic for this session is decimal number system and its conversions. If you do remember the last session, we talked about what is decimal number and how we can represent it. In this particular session, we will talk about how to convert decimal number into other number systems. To generalize this process, to convert decimal number to any B-based number system represented as capital X to the base 10, that is decimal number, to small x to the base b, that is b based number system, is as follows. Firstly or initially we need to divide the decimal number capital X, that is dividend, by b, in which b is the base of the number system in which we want to convert. So we need to divide the decimal number capital X by b divisor and record the remainder. Again, considering the quotient received from the first step as dividend and b as divisor, we repeatedly divide and record the corresponding remainder till the quotient is 0. Record the remainder of each division and reverse it. For instance, the last remainder would be the first digit in the b based number system on the left. Let's understand this with the help of an example. For instance, we are trying to convert a decimal number to binary number. To convert number 66, which is in decimal, to base 2, that is binary number, equivalent represented as 66 to the base 10, decimal number 66, converted to small x to the base 2, that is where x is the binary number or binary equivalent of 66. So in the first step, we divide 66 by 2, we get 33 as quotient and 0 as remainder. So we note down this remainder as we discussed, right? In the next step, we divide the quotient of the previous step by 2 and we get 16 as a new quotient and remainder as 1. So we rearrange these remainders starting from the right side moving towards the left. So the first step remainder becomes the rightmost bit of the binary number and the remainder in the second step becomes the second last digit from the right. Step 3, we again divide the quotient received from step 2, 16 by 2 to get 8 as quotient and 0 as remainder. So now we put this 0 on the third last position starting from the right. Similarly, the step continues till we get 0 as quotient. Just to point out, in step 6 we got 1 as quotient. So although 1 is less than 2, but still divide in step 7 1 by 2 to get 0 as quotient and 1 as remainder. Now this 1 at the end of the step 7 becomes the leftmost bit or the digit of the binary number system or a binary number. So hence 66 in decimal is represented as 1 0 0 0 0 1 0 in binary. If still it's not clear, so we have different method or another method to understand this conversion. Suppose we have a decimal number 34 and we want to convert it into binary. So firstly or initially we divide 34 by 2 and we get 17 as quotient and 0 as remainder. Now the quotient in the first step is 17, which now becomes the dividend, and we divide the 17 by 2 to get 8 as quotient and 1 as remainder. Now the quotient in the second step is 8, which becomes the dividend in the step 3, and we divide this 8 by 2 to get 4 as quotient and 0 as remainder. Now the quotient is 4, we again divide this 4 by 2 to get 2 as quotient and 0 as remainder in the fourth step. And in the fifth step, we divide the quotient received in the fourth step, that is 2 by 2 to get 1 as quotient and 0 as remainder. Finally, the 1 which is the quotient in the fifth step becomes the dividend, and we divide it by 2 to get 0 as quotient and 1 as remainder. Now if you do remember, the process that we talked about in the first slide says, now we have to, the bits we have or the remainders that we have received, we need to reverse them, right? We'll consider the last remainder as the leftmost bit, and we'll consider the first remainder as the rightmost bit. So we start placing the first remainder at the rightmost end, then the second remainder at the second last position from the right. Similarly, we place the other remainders, placing the remainders in the reverse order from left to right. Left means 0. The first 0 will move to right at the last, bracket says last. So first 0 goes to last, and then 1, that is the second remainder, moves to second last position. Hence the 34 in decimal is equivalent to 1 0 0 0 1 0 in binary. Now still, if it's not clear, we have a very simple method to clear all our doubts before we move ahead with other type of conversions. The third way to understand the conversion of decimal number 34 is as follows. So 34 is divided by 2 to get remainder as 0. So we write the remainder first and then we write the quotient. So 17 is the quotient and 0 is the remainder in the first step. Now the 17 is again divided by 2 and we have 8 as quotient and 1 as remainder. Now this 8 is again divided by 2, then we have 4 as quotient and 0 as remainder. Now this 4 is again divided by 2, it gives us 0 as remainder and 2 as quotient. So this 2 is again divided by 2 to give us 1 as quotient and 0 as remainder. Now this 1 is again divided by 2 to give 0 as quotient and 1 as remainder. So now, as per the first slide or our protocol, we have to move in the reverse order. So we'll move from the last remainder to the first remainder. So moving from bottom to up, 34 in decimal is equivalent to 1 0 0 0 1 0 in binary.